Algebra II students, we are back with another section. This one is Chapter 1.8, Recursive Formulas for Sequences. Now, you might be asking yourself, what is a recursive formula? Yes, I had the same question. The way I like to think of recursive is it comes from the word recur, which means to look back. So if you can think about this picture, it might help you remember how to write this, how to use this formula for sequences. You want to basically write the pattern based by looking back at the previous term. So as a review from section 1.7, a sequence is just a list of numbers, and in this case it follows a pattern. So you have to do two things to write the recursive formula. First, you have to tell the first term. Okay, and then the second thing is you got to tell how to get to the nth term is related to the previous term. In other words, you got to tell me how to get to the next step from the step that I'm standing on. So I like to think of it as a ladder, where if I know the first step and then I know how to get to the next step from the step I'm on, then I'm going to be able to climb the ladder, because I'm going to know how to be on the first step, and then I'm going to know how to get to the next one from the one I'm on, so I can just keep climbing up, and I can generate each step of the ladder. And think of each step of the ladder as a number in the sequence. Okay, so with that, let's look at a recursive sequence. So as I said, you need two things, the first term, so usually we call that T1. So T1 is equal to 2. That means the first term is 2. The first step is 2. Then you have to tell me how to get to the next term from the previous term. So we say Tn to represent the nth term. N is the placeholder. It tells us like what step we're on, right? Like if n is 3, it means we're on the third step. And it's equal to the previous term squared plus 1, where the step has to be 2 or greater, because we already took care of step 1, where n was 1. And we need to write the first 3 terms of this sequence. All right, so pause, try to do it yourself. Okay, so the first step, the first term, we're just going to copy it from the first line. It's 2. Then to get the second step, T2, it says, okay, take the previous term, which is T1, square it and add 1. Well, the previous term is 2, so we square 2, add 1, and we get 5. So 5 is the second term. And we just need the first 3 terms, so we'll get T3. To get T3, it says, okay, take the previous term, which is T2, square it, and add 1. Well, what was the second step? What was T2? It was 5. So we just do 5 squared plus 1, or 25 plus 1, and so we get 26. And those are the first 3 terms. It's all we need. It's all we're asked to find here. So the sequence at least starts out with 2, 5, and then 26, and then so on, and it follows the pattern. Okay, so that's an example of using the recursive formula to generate the sequence of numbers. Now, let's look at another example. I'm going to give you the recursive formula again. So consider this sequence defined by the recursive formula. So because of the recursive formula, you know I'm going to give you the first step, and then I'm going to tell you how to get to the next step from the previous step. So the first term is 6, so T1 equals 6. Then we say Tn, to represent the nth step, equals 3 times. Now, before I wrote previous term, but that takes a lot of letters. I'm pretty lazy to do that. So instead, I'm going to write Tn minus 1. Because if you think about it, if you're on the nth step, like if n equals 3, then n minus 1 would be 2, so that would be 3 times T2. So Tn minus 1 is a shortcut way to write previous term or previous step. So the way this one's defined is Tn equals 3 times Tn minus 1. Again, Tn minus 1 just means previous term minus 5. All right, we need to write the first 5 terms of this sequence. So the first term, we're just going to get right off T1. T1 is 6. To get T2, it's 3 times, well, T2 minus 1 is T1, so it's 3 times 6, which is 18, minus 5 is 13. To get T3, it's going to be 3 times the previous term, which is 13, so that's 39 minus 5 is 34. All right, I need the fourth term and the fifth term, and then I'm done. So the fourth term, T4, 3 times the previous term, which is 34, minus 5, it's going to be 97. And then finally, the fifth term is 3 times the previous term, which is 97, minus 5. So I'm going to get a whopping 286. And there, I've got the first 5 terms of my sequence. So I'll write out the list, because again, the sequence is just a list of numbers. So it's 6, 13, 34, 97, 286, ... to represent that the sequence keeps following the pattern. And I'll highlight that answer. All right, so you might be thinking, okay, great, thanks a lot, Ajan, for figuring out these sequences, but when would I actually use this, right? So I'll give you an example. So let's say our very own Chanuknan starts a job, and she's taken my personal finance class, so she's wise in the ways of money, and she knows that it's a good idea to take part of your paycheck each month and put it in a savings account so that you build up a savings. So you can do that through something called a payroll deduction plan, and the idea is part of your salary just automatically gets put in a savings account, so you're not tempted to spend it, right? So she starts a new job and she decides to enroll in this payroll deduction plan where she's going to save a certain amount of money each month, right? So the first month, they have different levels. You can save, a lot or a little bit. And she's like, okay, the first month I'm going to try and save 10,000 baht. So I'm going to have 10,000 baht deducted from my monthly paycheck. But then she realizes, man, that's too much. I actually need more money than that. So I'm not going to take away so much money and put it in savings. I'm just going to make sure that I save 5,000 baht each month after the first month. Okay. So let us, we need to write a sequence that, and we want it to be a recursive sequence in this case. So write the recursive formula for the sequence that will represent the amount of money that she saved after n months. So if n is 4, then we should get how much money she saved after 4 months. So again, n tells us what spot in the list we are looking at. So in this case, each number represents how much money she saved in that month. Okay, well, because it's a recursive sequence, well, first let's just try and write the sequence a little bit. So the first month she's going to save 10,000. Then the second month she saved 5,000. So in total she saved 15,000. Then next month she saved another 5,000. It's going to be 20,000. And then the fourth month she's going to save 25,000 total because she's going to add another 5,000 for that. All right, so that's what the sequence looks like, but we got to write the recursive formula. We need 2 things for the recursive formula. 2 things. The recursive formula, the first thing is always going to be, we got to give the first step. So that's fine. We just find the first step. It's 10,000. So we just say T1 equals 10,000. Good. Then we have to say how to get to the next step from the previous step. So it's always going to be Tn equals something with Tn minus 1 in it, right? Well, in this case, we see the pattern is you just add 5,000 to the previous step to get to the next step. So how do we write it? Tn minus 1, which is the previous step, plus 5,000. And we can test this out in month 3. We should get T3 equals T2 plus 5,000, and T2 is 15,000. So plus 5,000 is 20,000, which was what we wanted. So we're very happy.